Hi, and welcome to Q's Workshop. Today I'm tackling a little bit of a different project. So the wigwag build is still on the go, but I thought let me just mix things up a bit this weekend and tackle this. So what I've got here is a magnetic display DRO, 3-axis. So I got this off AliExpress probably about a year ago, and it's been lying here in a box. Just haven't gotten around to it. So I thought, let me change things up a bit and actually get this installed. With that, I've got a tachometer, which I'm going to look to just put alongside it. I don't know really how relevant it is installing the tachometer on the lathe. I mean, literally on the hand dial, it's got a big arrow that points to the speed that it's running. So I guess this will just show how accurate that really is. But yeah, this is essentially what I'm going to tackle the weekend. So for mounting wise, I've actually had this old computer speaker lying around, which I stripped out some time ago, and I kept the box thinking I want to actually maybe use it for something. And lo and behold, this project comes around, and these two things actually fit in here relatively well. For that, I 3D printed, so I just designed this up in Onshape, an online CAD program. So I designed this in there, and it ultimately just fits on there like that. It's going to get knurled inserts melted in over there just for screwing it down, and then the screens will fit in there. The only thing that I'm still looking at is the orientation of the screens. So I don't really want it standing up vertically on my lathe because it's going to take a lot of real estate of the whiteboard that's behind my lathe. So I've got a whiteboard that's at the back, and if it stands upright like this, it's actually going to take some of that whiteboard. So I'm looking at potentially mounting it like this. The only downside is the tachometer is going to have to be vertical then, and obviously the numbers are going to run upright. So that's the only downside, but at least it doesn't take my whiteboard by mounting it like this. So yeah, that's essentially for the mounting of the screens. For the DRO, it comes with magnetic strip that you actually have to stick down onto something, obviously something flat. And it comes with a stainless steel strip that goes over the magnet to protect it. And then obviously you get 3 of these for each axis for the DRO. I've got, for the magnetic strip, I've actually got some of this aluminium angle, which it's not very rigid. It is flat, so I've checked the flatness of it, so that is fine, but it's not very rigid. So what I've actually done is I've stuck 2 pieces together, and I'll use it like that because it just creates a little bit more rigidity on this. But yeah, it is perfectly flat. That's all been checked. For the tachometer, I've already created just a little bracket that will fit onto the spindle of the lathe. So this is on the main spindle. This just fits onto the one side, and that's to hold a magnet. And then, so what happens is you've got one of these little probes, and every time the magnet passes the probe, it essentially reads a revolution. So this will be mounted close enough to that by the spindle, and then that spins and the probe picks it up. But yeah, this is essentially everything that's got to get mounted. I will also look at if there's space in here to get a little 12-volt power supply mounted in here. Otherwise it will just be separate, and I'll just have a port on the back that it can plug into. But both of these will run from that 12-volt power supply. But that's it. let's stick around. I'm not going to be recording everything, every little step, you know, drilling and tapping holes on the lathe and those kind of things. There's a lot of videos out there on how people mount scales on the lathe, but I will capture some of it, some of my journey on getting it mounting, and yeah, stay tuned. Right, so first up I'm just going to do this faceplate and get these little inserts in. So I've got this little universal inserts kit. So I've got the size that I'm looking for, and usually the best way to do these is just to melt them in with a soldering iron. So I've got a gas soldering iron, just heating up here quickly. But the first, so I had another faceplate. The holes weren't the perfect size, and then I just trialed the best way to drop these inserts in. So I'll first try to hit it in with a hammer, but it deforms the plastic a bit, so and then they slip out a lot easier. And then obviously the next one I tried just melting it in, and that seems to work a lot better, because it actually melts the plastic around the inside of the little knurled insert. So it's got like a little hole there. Let's just heat up the bottom of it, and then we'll push it in. Just leave that to cool down. Right, let's get the things mounted. So what I've done is I've also decided I'm going to put it vertically like that. The reason for that is the edge over here, if I put this in horizontally, it actually hangs over the end here, which then hangs over the bottom. So trying to have it stand horizontally like that, I'm actually going to have to put it on something, because otherwise it's going to sit on the edge here, because it overlaps. So I'm going to pop this in like this, and then I'll just have it vertically on top of the lathe. I didn't want it like that originally, but let's go with it. I've also taken one of these and that actually holds it down, so the clamping piece, I've taken one of those and I've just cut it down short and made it a bit smaller. It doesn't have to be that size to actually hold it in here. It's just that there's essentially just less stuff in the inside, and then because I've cut that down, I've got these little pieces of just sawn off pieces of nail that goes in there, just to take up the gap, because this hole is not threaded all the way through. It's just let's say the top third that's threaded, so I've just dropped that little piece of nail in there to take up the space. Let me put that in. Right, so that's that, and then the screen goes this way. There we go. So that's how it's going to stand now. I'll probably just leave it, let's say, loose, so that I can move it out the way if I want to use the whiteboard, or if I've got something behind it on the whiteboard, but that can just be rearranged. Right, next up I'm just going to do the power terminal and switch. So I've got it running there now. I'm just testing one of my older 12-volt power adapters. It's got a little buzzing sound on it. Wasn't sure if it's still working, so I'm just running it there for a while. But that's why I'm just going to stick a terminal on the back rather, so I can switch out the power supply if need be, and then just a little toggle switch for the power. basically all I'm going to do is I'm just going to replace those two wires with this here. Right, so I just cleaned up a bit here, but there it is. So we've got the power switch, the plug. So through this hole, I'm just going to have to make it a little bit bigger for those plugs to run through. For the little reader heads will go in there. Unfortunately, I wanted to mount them on the back here so that you can just plug them in, but I'm going to have to, if I wanted to do that, I'm going to have to desolder all of those that are there because they've been soldered already, and to be able to pull the plug cover off, you actually have to remove the solder. So I'm just going to leave it. I'll run them in there and connect them and have them lying loose inside. Right, so I've got everything buttoned up and put back together on the lathe. The only things that I did additionally was I put some of this cable management trunking kind of stuff that's usually used behind computers and things like that to just clean up your cables. So I've got some of that on the wire just to keep hot swirl from landing directly on those wires. Some might fall in there, but at least it'll protect it a bit. I've got a aluminium baking tray under my lathe, and the side wall of it is about 40 millimeters, maybe even 50 millimeters. That stops kind of swirl from falling to the back of my workbench, and the cable is running behind that, so it will protect the cable that's running to behind the screens. I also, for the tachometer, installed the sensor and the magnet that has to go onto the spindle. So it's just a little round bracket that fits over the spindle, fastens with a grub screw, magnet gets stuck onto that, and when it spins it reads ultimately. So I've got the lathe set at 550 at the moment, so you can just check how accurate it is. So it picks up relatively accurate. It does take a little while to kind of find its feet. I did notice it's usually about 10 revolutions over what my lathe is saying. Whether that's the lathe that numbers that's wrong, or they kind of just rounded up estimates of the gear sizes, or if the meter isn't picking up 100%, but I mean 10 is close enough. At the end of the day, it's more just a indication than anything else for me. Then for the DRO itself, so overall I think it's a nice DRO. I mean, it's for the price that I paid for it, it's definitely going to do what I need it to do. It's just literally just as a reference when I'm cutting down work, being able to zero, cut some, and have a reference point. So if we just take a look at some of the settings, so just on the front, we've got date and time, we've got the battery indicator there, so it has got an internal battery for, not for using, but just to store the settings. So if I turn off the plug, it will turn off, but it's just to save your settings. And those settings I'll get to in a second. So, well, I guess the first setting is the date and time. Obviously, if the battery's flat, it will lose that. But if we just go into the main settings, so main settings, you've got your date and time that you can configure. You can reset factory settings on it. Language, English and Chinese. User data. So here you can actually save or back up your user data. And again, we'll get to some of what that user data is in a second. And then you can restore it. So if the battery has run flat because it's been off for too long, then you can just restore your settings. And then shafts, which is the amount of axis that you're going to actually use. So you can set this to 2, and when we go back to the main screen, you'll actually see the z-axis is now it's not configured, or it's not going to get used, is the z-axis. But I've got the z-axis for my lathe, so I've got the z and the x set up for it. So the one is the carriage and the one is the cross slide. And the Y, I guess in the future I'm going to look at putting Y onto the tailstock. I was going to just use a digital caliper on it, which I took off the mill that I originally had on the quill of the mill. But I think I'm just going to add the Y on there. But if we just go back in there and we just change that back to, we're going to use all 3, we'll keep it like that. Right, so that's just the main settings. Then for each of the axis has got a setting area of its own. So if I just go into the X, I hold the button for X, it goes into the X configuration. I've got the initial, so this is essentially where I can 0 on something and I can put in a value that I want it to be. So kind of I put in 12 or -12, whichever you want it to be. I press F to save it. Now my X becomes 12. And it doesn't matter how much I move this. If I 0 it, it goes 12 again. So 12 kind of becomes my home point then. It doesn't have a absolute setting on it. So your absolute incremental, it doesn't have that. I don't know, with this kind of setting, being able to set that, I don't necessarily think that takes the place of a incremental absolute setting. I don't think so. Let's just set that back. But next one is direction. So kind of you can change the positive and the negative depending on which way you've set up your reader, the little sensor on it. Then there's, I'm going to skip correction for now. Function. You can set the millimeters, inches, or angle. Proportion factor, I'm going to skip that one for now. Disc diameter. So disc diameter, I'm not quite sure why you would set it here. I don't know if it has to do with this angle setting on there. It's something that you would use for between those two. But I ultimately just set this one for, because it's my cross slide, I've set that at 225 because that's probably the biggest that I would hold in my chuck. Maybe I could probably hold a bit bigger, but that's essentially what I'll hold. So I just made it 125. And then the resolution, 0.01 or 0.1, you can set that as well. Right, now to 3 of them, the last 3. So the very first one is correction. So this is something called self-correction. And what this does is it allows you to configure the machine for a self-correction. So once I set this, so if I go in here, it allows me to move my hand wheels on the lathe, and then it tries to acknowledge what is happening as I'm moving. and then it tries to compensate for that. I haven't had much success with that. I always just get error when I do move. So if I move this one, there you can see error 9, which error 9 is that the magnet is too close to the sensor. The other error, E10, is the magnet is too far from the sensor. Those are the only two that I've managed to get. I never get it in a place where it's actually going through the percentages, because what it's supposed to do is that percentage sign there is supposed to eventually reach 100%, and then it saves itself as that self-correction. And then you're meant to do that every time if there's substantial changes in temperature and those kind of things. You're meant to do this self-correction again. I haven't had much success with it. I don't know if I'm doing it wrong, but I'll probably give it a go when I try and mess around with other settings. Next one is the proportion factor. So this is where I'm going to need some help, and please drop something in the comments if you understand these two. So the one is the proportion factor, which as far as I understand is, again, a compensation over distance. So if I'm moving from 0 to 100 millimeters, and if I do a true measurement with something like a caliper or a dial indicator, I move the 100 millimeters, and it's actually moved 102 millimeters on the DRO. There's a certain amount of compensation that's needed, that proportion factor, which could be 0.01. So every millimeter that it thinks I'm moving, it needs to minus that 0.01 from that millimeter, so that the DRO reads exactly the same as what a dial indicator, for instance, would. So that's the one, proportion factor. Now that's my understanding of proportion factor, but again, please let me know in the comments if that's not right. The second one is multi-compensation. So multi-compensation is quite comprehensive on here. So if I just go into that setting, it allows 9 different compensations. Okay. And this is so taking the bed of the lathe or kind of the cross slide on the top, taking that and dividing it into 9 areas, you can add a compensation for each of those areas. So for the first, second, ninth, because there's certain areas of your lathe where you work more than others, and wear and tear and those kind of things is taken into consideration here. So you would set certain areas to compensate more than others. So it allows for 9 of those settings. But as far as my understanding is, it's kind of the same as the proportion factor. It just allows kind of deeper configuration on very specific areas of your lathe. But yeah, again, if I've misunderstood those, please let me know in the comments. Then, you know, if you can explain a little bit how to even set those, that will be appreciated. I was literally just going to take my dial indicator, drop it on, move it very, slight amount, and see if it's correct or not. I tried using the scale on the hand wheels. I don't even know how accurate those are, so I don't really know if it's close or not. But yeah, that's it for kind of the settings per axis. If we just get out of that. But that's it for the DRO. Only the last thing is kind of just maintenance-wise. Obviously, with these being magnetic scales, swarf will stick to it very easily. So I've got some of this kind of little brush that you would put by windows and doors to keep dust and things out. I'm going to try and stick some of this close, kind of by the reader, maybe like that, with it pointing up, and then when it's moving, it can sweep the magnet clean as it's running on there. I have tried to protect the magnet, at least this front one, that's going to probably catch the most swarf, but I'll see if I can stick some of this in to keep the magnet clean. But that's it for today. Thanks for watching, and sorry again for not capturing everything that I was doing. It was just a little bit difficult to hold the camera behind. I probably could have had a camera stand up, but it was a little bit difficult holding camera and doing things with both my hands. But yeah, if you want any information regarding this DRO, if you've got any questions, I'll pop a link down in the description of the one that I purchased. I'll stick things in there. At least you know now what you're going to get when you purchase that one. But thanks for watching, and I'll catch you in the next one.